everyone, my name is Miniseti. I hope you all are staying healthy. Today we are going to talk about homogeneous and homothetic function. First of all, we are going to talk about homogeneous function. Homogeneous function is one where all input variable are multiplied by scalar. Homogeneous function is one where all input variable are multiplied by scalar. Scalar means a single numerical value, for example k. Homogeneous function is one where all input variable are multiplied by k. Then entire function of output also multiplies by k raised to some power like n. Please listen carefully. Homogeneous function is one where all input variable are multiplied by k. Then entire output function also multiply by k raised to some power like n. We will clearly understand with the help of one example. This is our function. Here x and y are our input variable. Suppose we multiply both x and y with k, or you can say that x is increased by k time, y is also increased by k time. When both x and y are increased by k time, then our equation will look like this. We will take k common. Here k raised to the power n. Power can anything, but here we assume n. And this is our entire output function. So here you can clearly see when we multiply our input variable with k, then entire output function also multiply with k raised to the power n. This will be called our homogeneous function. Here what is n? N is a degree of homogeneous. By n you can know nature of a scale. For example, if n is equal to 1, that means constant return to scale. If n is more than 1, that means increasing return to scale. If n is less than 1, that means decreasing return to scale. Now we understand homogeneous production function with the help of one example. This is our Cobb-Douglas production function. We have already discussed about Cobb-Douglas production function. Now we will check is this homogeneous production function or not. So labor and capital are our input variable. We will multiply our both input variable with lambda, or you can say that L increased by lambda time, K also increased by lambda time. When both input are increased by lambda time, then our equation will look like this. So A lambda raised to the power alpha, L raised to the power alpha, lambda raised to the power 1 minus alpha, K raised to the power 1 minus alpha. We can write lambda raised to the power alpha and lambda raised to the power 1 minus alpha. And A will come here, A, L to the power lambda, K to the power 1 minus lambda. This alpha will cancel with each other. Now our equation will look like this. This is our entire output function. This is our Q1. So in place of this we can write Q1. Lambda raised to the power is 1. So here you can see when we multiply our input variable with the lambda, then you can see our entire output function also multiply with the lambda raised to the power 1. So it will be called our homogeneous production function. Here lambda raised to the power is 1, that's why it will be called homogeneous production function of degree 1, or you can say that it will be called linear homogeneous production function. Now we will see homothetic function. Monotonic transformation of a homogeneous function will be called homothetic function. Monotonic transformation of homogeneous function will be called homothetic function. So here you can see this one represent homogeneous function, this one represent homogeneous function, and H represent a monotonic transformation. This whole represent a monotonic transformation of homogeneous production. That's why it will be called homothetic function. Now we will see, is this function homothetic function or not? Homothetic function is monotonic transformation of a homogeneous function. Here x and y are our input variable. First of all, we will see x square y is a homogeneous function or not. In order to see x square y is a homogeneous function or not, we will multiply our both variable x and y with lambda. So when we multiply our both variable x and y with lambda, it will look like this. Lambda raised to the power 2, x raised to the power 2, lambda y, it will become equal to lambda cube x square y. So here you can see when we multiply both variable with lambda, then our whole means our entire output function also multiply with lambda raised to the power 3. This is our entire output function. So here you can see our entire output function also multiply lambda raised to the power 3. So we can say that x square y is our homogeneous function. So here x square y is equal to gxy, means now we have proved this part is our homogeneous function. So we have proved this is homogeneous function. Now we will prove is this H monotonic transformation of homogeneous function or not. In this equation, in place of H we have E. Now we will see is this H a monotonic transformation of homogeneous function or not. What do you mean by monotonic transformation? Monotonic transformation means increasing function of original output. That means if you increase input, then definitely your output will increase, or you can say that when you differentiate this H with respect to X or with respect to Y, then value will positive and greater than 1. If all conditions are fulfilled, that means this H is a monotonic transformation of your homogeneous function. So this part is a homogeneous function and this H represent monotonic transformation and this whole represent a homothetic function. So this is all about today's video. I think you got it and thank you so much for watching this video. Bye. Take care.